Where the heck are all these minions?
That no one low below Siri. No what happened to that?
No, my friend. The truth is like painful medicine, eh?
Russian.
And I'm just trying to
Russian.
help you guys take a big gulp of that medicine. All right. So instead of investing in your girlfriend or boyfriend, invest in a good computer. It's gonna last you a long time. All right.
No, I heard that mission right there.
That's right. And if you feel like lonely or whatever, ask Leah what happens after she got married if the honeymoon phase is over and she goes, damn man, I enjoy being single. What the hell is this? Single life was the best life. So then yeah, that's just like a reminder. Just go up to like married people and ask them, how's it going, man?
You want to have to find your date sometime soon, or sir?
Find my what?
Your date.
That's true, man. That's true. I have to. I'm gonna find one on Belize buy and sell.
No, sir. Have mind their prices, you know, sir.
Only Kendra today.
What? Kendra? Who's Kendra?
Look it up, sir.
I don't even want to know. The fact that a lot of you know what Kendra means, that means some kind of weird thing. I don't want to know. I don't even know what Kendra is. I don't want to know what Kendra is. All right. So let me. I don't know where the rest of the people are. This is a
What
full
the
house.
Kendra?
I have no idea who Kendra is. Okay, guys. So back to this.
Shut Kendra, and I'll send you later.
All right. Let me share my screen. Okay. All right, back to this beautiful stuff. So now we've established who this guy is, List, right? List is the coach. This is the guy who's going to manipulate all of those list nodes, and that's why list node had to explicitly tell the compiler that list is its friend, because no other class would have the right to be able to tell a list node, hey, I want you to attach your next pointer to another node. Just like nobody can go up to some random pickup and attach a trailer, right? It's not your pickup. You don't have a right. Yes, the pickup has a hitch, but it's not your. You don't have rights to that pickup in order to do something like that, right? It's the same principle here. All right, so let's look at the code for this class. And again, line 11 basically says that this is not a regular class, it's a template class. All right, and then if I again ask you this question, I said how many member functions are in this class? The constructor is a member function. It's just a function with a very specific job. That's why he has a title like that. This is the destructor. You have not seen destructors before, but a destructor looks exactly like the constructor. If you can, as you can tell, same name, same spelling, everything. The only difference is you prefix a destructor with the tilde. That's it. All right, that's the only difference. You can only have one destructor per class, but you can have as many constructors as you want, right? So just remember, only one destructor, but as many constructors as you want, as long as, if you remember that's programming one, as long as your parameters are different, you can have as many of these as you want. Perfect. Now, how many member functions do I have total? I have
9.
1, 2, 3, 4, 5, 6, 7, 8, 9. All right, you have to count the constructor twice. That's just how you do it. And that's why we end up with 9 member functions. How many data members do we have?
2.
3, because you have to count the first one twice. So it'll be 1, 2, 3. So we have 3 data members. Correct? Does that make sense to you guys?
I appear so, sir.
So if you guys made sense out of that, then you need to casually slap yourself in the face, because that was complete rubbish. I just told you. There are 9, but the 9 are, these are the first 8 here. Oops, 8. This is the first 8 here to here. And then this is the 9th one. And the reason why last time none of you could tell me that there were 9 is because your mind, the way your mind works is your mind already knew that data members, come on, dude. Data members are private, and you're thinking, oh, there will be nothing in this section except data members. But what you did not realize is that you can have private member functions and public member functions and protected member functions. The only issue is that in the past, you've only experienced member functions that were placed under the public section. But now we have, well, now you're seeing that you can actually have functions within the private section. What does that even mean? Why would I do that? Why wouldn't I want to put this in the public section like all the rest? Well, this is the reason. Any function that has been labeled as private basically means that that function is unknown to the outside world. And you're thinking, why would I create a function that nobody knows about or can call? Remember, you can only call an outside class can only call functions that are public.
No, bit black.
So they can call any of these,
What is your change?
but they can't
Can you
call
open
this
your
one. And the question is, why would I build a function that is private that nobody knows about or can call? Well, it's because this is not for the outside world, right? So outside
192
world,
tu want check eh?
world. Okay, hold on. Outside world, not for the outside world.
122.
All right. This is for
122 tu want check.
these guys.
122 po.
All right. It's to make their life easier. So these guys can call this guy to do the work for them. All right. Does that make sense? So a private member function is usually referred to as a helper function, all right, or a utility function, because these guys help your other functions. They are utilities to these functions. To the outside world, nobody even knows this thing exists, all right? Nobody knows that these things exist. So the only purpose they serve is to help these guys. So behind the scenes, so the outside world can call any of these. And the outside world does not know when this guy says, all right, that's cool, I will call this guy. The outside world does not know, does not care. Does that make sense? How these guys achieve their jobs, nobody cares. So that's why we have private member functions. So now back to this. We have insert at front. So let's do this. I will, at this point, basically build a list, a linked list, and we will see the actual process from scratch. We're going to follow the code from scratch, and then you're going to appreciate what's going on, right? So let's go to the, let me go to the driver program. Okay. Okay, that's not a good idea. This is going to scare you. Hold on. Let me gradually scare you instead. Right. Okay, so let's do this. I'm going to draw main. So this is main, right? So this is main. This is main. So that was supposed to be piece, but anyway. So now, inside of main, right? I'm going to do this. I'm going to create. So who do you think I should build inside of main? Should I build a list object or a list node object? Now, whenever I ask you a question, I want you to really think about your answer before you give me an answer, right? Do you think in order to build a linked list, I need to build a list or a list node?
A list node, sir.
A list node? Okay, anybody else?
Oh, that's node.
List node. So actually, we need to build this guy first, all right? This is like the jeweler. This is like your human being with the pickup truck, all right? This is like the coach. These are the entities that are actually necessary, because even if you build list nodes, somebody has to know that they exist. Somebody has to know how to attach them. So that somebody must be created first. So the first line of action is to create one of these objects. So now you tell me, based on the code you're looking at right now, walk me through the process. If I asked you to build a list node, a list object, tell me what you would do. How would you build a list object? I'm inside of main. Remember, this is a separate file. This is a completely separate file. Let me check my chat, because you probably are just chatting away and giving me answers and I don't even know. Come on. on, man. Show it. Chat. Okay. Okay. So, what's your response? How would I build a list object? Come on. What the frick did I do?
All right. So yeah.
Hold on, sorry. Huh?
Okay, so list.
How do you build an object of any class? Come on, guys. This is programming one stuff. How do you build an object of any class?
Name of the class and
Name of the class.
object.
Name of the class. My class is called list. Okay. And then you give your object a name, correct?
Yep.
I'm going to call it L. Bueno or no bueno?
No bueno.
¿Por qué?
That
Because it's
Because
a template
what?
class.
Because what?
Because this is a template class.
List is a template class. The compiler is going to go and say, you can actually build a class from this. This class has missing parts. You need to tell me what you want me to fill the missing parts with. Right? Look at line 11. That's what this is saying. Line 11 is saying this is a template class. He has missing parts. Look at the missing parts. Missing, 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 missing. Right? Missing, missing. All of these things. The compiler cannot build an object of this class. This is a template. What you need to do is tell list what type of list you'd like to build. So I'm going to, okay, now I gotta use the eraser because I can't erase everything. And so I'm going to do that. And what am I going to do now? So what do? I put the angle brackets. I put the angle brackets and I say, I want to build a list of what? Integers. And I'm going to name my list L. All right, because L is just short enough that I can get away without getting bored. So I just built this dude. Now, listen carefully to my next question. Listen carefully. If I asked you, okay, let's backtrack 1 second. Let's backtrack. Who just got called when this line got executed? Who just got called?
The
Constructor.
Constructor. Whenever you build anything, the constructor gets called. Now, I'm not going to show you the code for the constructor. I'm not going to show it to you yet. I want you to tell me, based on your experience from programming 1, programming 2, and all the stuff you've been learning on your own in your free time, because I know that's what you all do, right? What does the constructor actually do? What's the job of the constructor?
data member.
initialize data.
Initialize data members. Now, looking at this code, how many data members does this class have?
2.
Two. So if I asked you right now, right, I said, hey guys, I want you to draw what do the visual representation of what that code produces, right? So if I said, okay, this code produces a list object called L, and I asked you, all right, do me a favor, just draw something that makes me that I can see what this code does, right? Give me a little visual. What would you draw on the screen if I asked you to do that? What would you draw if I told you to draw a list object? What would you draw? There's only a little background sound of crickets. It'd be perfect time to play.
What was the question?
Oh my God, what is the question? Listen again. If I asked you, draw what a list object looks like after it's built, just to give me a visual, right? Just something that I can look at. What would you draw on the screen? Oh God, this person's actually drawing.
Would it be int first PTR and int last PTR?
Okay, let's pretend whenever we draw an object, let's do it as a circle. You could do it any shape you want, right? I was doing my list nodes as rectangles, but you could do anything you want, right? Let's do it like this. I'll just do, just so it can look different, right? I'm going to do a circle. It could be a square, it could be a rectangle, it could be a triangle, whatever it like tickles your fancy, right? So this dude, you see this dude? Who is this dude in my diagram? Who does this guy represent?
Object.
Which object?
This object.
L, my list object L, correct? Now, if this is the object, and I said, if I were to ask you to cut this thing in half, what would I see inside if I were to look inside of this list object?
First PTR and last PTR.
First PTR and last PTR. Remember, data members make up an object, just like a human being. If a human being goes to a surgeon, let's say because they hurt their knee for whatever reason and they have to like do surgery, right? When you cut it open, you're not going to find jump, you're not going to find run, you're going to find the parts that make up the knee, right? Which should be bones, tissue, like ligaments, whatever the heck. You're going to find those things. Those are the parts. This is what makes up an object. So inside of this, I'm going to find, and I don't want to write first PTR. Just remember, just this F means first PTR. All right? But the F you see on your grade, that actually means fill. Just remember that. This, I'm just being very clear here. This F here means first PTR. And this is, oh, maybe I should name this L because you're going to get confused. Let me call this LI, right? LI, so you're going to confuse it. This is LI. My object is called LI. This is first PTR. This is last PTR. Good. So now, what's this guy's job? This guy's job is to point to what? List nodes, correct? Is there any list node currently in my linked list? When you first build a list, do you see any list nodes? Are there any list nodes?
No.
When you first, no, it's this guy's job to recruit, right? I am a coach. I need to recruit players. All right? There are no players when the team first starts up. There are no players. The coach's job is to recruit the players. And it's the same principle here. This guy, when you first build a list, there are no list nodes. This guy's job is to build those list nodes and then have them attach one another. You understand? So when I first build this dude, there are no other list nodes. Now, the question I'm going to ask you, this is another very important question, which is, what the heck is the role of first PTR and last PTR? Why, like, okay, first of all, what are these? These are what? Tell me what these are. What is first PTR and what is last PTR?
Pointers.
What the heck, where did I go? They're pointers. Pointers to what? Another very important question. What kind of pointers are they?
Daughter nodes. List nodes.
Okay, say it in really simple English. Pretend like you're talking to a little 7-year-old. What can first PTR point to?
Everything of the same type.
To a what?
To a node of the same type.
A node of the same type. Okay, let me backtrack. Let me see if you guys are confused right now. Is the list class a self-referential class?
Yes, sir.
Yes.
How many people say that the list class is a self-referential class?
Yeah.
This is in.
It
Okay,
is.
so the answer is, why does my chat screen look like this? Okay, so no, the list class is not a self-referential class. Why?
Because with the function you have at front, at back, and then first PTR, last PTR. So
No. What makes a class? This is we're going backwards. What makes a class self-referential?
Doesn't call itself.
No. What makes a class self? There's one thing you have to look for. You go, oh, this is a self-referential class.
Pointer points to the class.
When you have a single data member, you can have more, right? But at least if you have at least one data member that can point to an object of the same class, that makes the class self-referential. List node is self-referential because a list node has a pointer that can point to another list node. Do you see anything similar to that in the list class? Does the list class have any data member? So you can't just say, oh, I see pointers, so this is a self-referential class. No, these are just pointers. Yeah, they're pointers, true, but this is not a self-referential class because these pointers do not point to list. If I had this, no, this is a self-referential class. This is not a self-referential class. You understand? This dude and this dude can point to what? What do they point to? What can first PTR point to?
The node.
A list node, not a list, not one of these. Not This guy can't point to another list, all right? He can point to a what? List node. This is a list node. A list node has data and a next. A list has a first PTR and last PTR. Don't confuse the two. This is my coach. This is my coach. This is my player. You understand? This guy can point to one of these. This guy can't point to the coach. Does that make sense what I'm saying?
So like it just act like I had one and feel like one to point to the first node and one to point
Right. Correct. So I need you to understand the parts before we can understand what the role is, right? So in this case, this guy can point to a list node. This guy can point to a list node, not to a list node. Why? Because when you build a linked list, right, you can't point to every single node. That's impossible because you don't know how many nodes you're going to have. All I really need is what? For me to traverse the linked list, for me to traverse it, and when I say the word traverse, I mean for me to go down this list, right? Visit every node. How do I visit every node?
all you need
All I
is
need
To
to know is
know
what?
the location of the
All I
person.
need to know is who the first guy is
all you
and
need
who the
is
last guy is.
where
Actually, I don't even know. I don't even need to know who the last guy is. I just need to know who the first guy is, and I can traverse this list.
you
You're
can
gonna
all
find
you
out.
need that start and you can say if it not equals to null, you then just continue going until you reach null.
Right. So in this case, I don't need to even know who the last guy is. I don't need to know that. You're going to find out why we try to keep track of the last guy. Not that we have to, but we do it for efficiency purposes. All right.
Like if
But this
you're
is not
walking
required. The reality is, I just need to know who the first guy is within my list. Once I know that, I can visit this guy. How can I visit this guy? Because if I am here, I can tell this guy, hey, dude, which address do you have stored? He says, I have 500. Okay. Then he goes to 500. When he gets here, he goes, hey, which address do you have? He says, I have address 25. And you come here. And he says, which address do you have? I have address 8,000. And then he can go like this. So once I know who the first guy is, I can get to anybody, right? That's important. So that's the role of these. Oops. Any questions about that? Does it make sense so far what I'm saying?
So far, yeah. So far, yeah.
Okay, so now we're gonna piece all of this together. So I was in main. I created a list. A list. Hold on. I don't know why it just does that sometimes. I create a list object, and I'm saying it's a list of type int. I'm gonna call it li. Visually, this is what it looks like. Right? This is li, and li has two parts, here and here. If this class had 500 data members, then this thing will be split up into 500 pieces. You understand? The first one is first, and then this one is last. Currently, does our team have any players? Does this coach have any players right now? At the moment when you first build this list, does he have any players?
Not
No.
yet.
No. Right? Your team has no players. So who are these guys pointing to? It looks like this. They're pointing to null. They're both pointing to null, right? Because there are no players. So now let's call function insert at front. All right. How do you call function insert at front? Well, function insert at front comes from the list class. So since I have a list object, I should be able to call this function. Yes or no?
Yeah.
Yes. So I'm going to say li, which is my object. I can call this now. I can say dot insert at front. Now look carefully. Insert at front says, if you want to call me, you need to give me a what?
The address of a node.
Okay, I'm going to explain this part right now, but let's pretend this part is not there for right now. What does this function say it wants from you when you call it? A what? When you look at a function and you want to find out what the function needs from you, where do you look?
At your constructor.
No, that function, this specific function, any function. If I pick a function, where do I look to see if the function needs anything from me? Parameter. Okay. So I just asked you the question. This dude just called insert at front. So my question is, what does insert at front want from you? You can't just call it. He wants something. This is what he's saying. He wants something. What is that something?
variable, like it determine the data type for it.
No. You have to be very specific. What does he want?
Address of an int.
¿Qué quieres, güey?
The address of a node type, which would be int.
He wants the address of a node.
No. Of a node.
Whatever it gives, it will convert it to constant.
No, don't worry about the word const. Don't worry about this ampersand. What does he want?
He wants
Int.
A node type.
A node type.
Which is
Question is,
int.
what the hell is a node type? Is node type an actual type in C++?
No.
No, that's just a name we came up with. We would have called it mule type. You understand? They call it node type. Now, when does node type get defined? Node type got defined up here. When you build a list of type int, that means everything from this point is of type int. So what he's actually asking you for is a what?
an int.
An int. So I'm going
Yeah.
to declare an int. I'm going to go here. Int. A is assigned 9. B is assigned 17. C is assigned 5. Let's just do that, right? And I'm going to pass in A. So now A contains 9. You with me so far? Now, tell me, without me showing you this code, right? Without me showing you this code, tell me what you think this code should actually do. Don't give me actual code. Just give me an algorithm, step by step, plain English. I want you to imagine, what do you think? This is the first question. Listen carefully to what I'm asking you right now. This function is called insert at front. What do you think this guy's job is? Like when he gets called, what do you think he's supposed to do?
Something.
Anybody? Anybody? All right.
Build the node with 9.
Huh? Build a node with 9 in it. Yes, build a node with 9 in it.
Insert it at front.
Okay, build a node with 9 in it. So build a node with 9 in it, and that's it. So this is what you
Insert
said.
it at front and then
Yeah.
name
Okay,
it.
okay. So build a node with 9 in it, and then insert it at the front, correct?
And assign that to first picture.
All right. So now, having said that, right? I want it to look like this. 9 is in there, all right? And I want, so let's just pretend, right? Let's just pretend that when I built this, his address was 500. I want this to come here, right? But if you only have one node in a linked list, that means this guy is the first and he's also the what? The last, correct? So that means I want last to also point to the same node. So the first step that this guy has to take is what? Build one of these. The second step is what? Check. If this list currently has no nodes, then this new guy that I just built will be the first guy and he will automatically be the last guy. Does that make sense?
Yeah.
Does that make sense?
Yeah.
Yes, sir.
Okay, so now let's do that code. Oh, shucks, I can't erase all of this. Hold on, let me erase just part of this. Hold on. So I want to do this now. Okay, so first step, build a list node. Sorry, yeah, build a list node. Second step, check to see if this is empty. I mean, if he's pointing to anybody. If not, we'll say first is assigned to list node and last is that. Okay, how do I build a list node? So pretend I'm inside of this function. Don't cheat now. You walk me through the process. Walk me through the process you're going to learn. What's the first step I need to do? Build a list node, correct? That's what's inside of this function. Build a list node. How do I do that? How do you build a list node? How do you build a list node?
To repeat the question, I never hear it just now.
I'm inside of the insert at front function. We already established the first thing this guy needs to do is build a list node. All right? Then he's going to figure out how this guy will treat it like if he's going to be the first guy, the second guy, whatever. So how do I build a list node?
First, you'll
Go ahead.
assign.
How do you build an object of a class?
So you already have the node object already, right? And then
No. We're doing that right now.
but you never already call insert up front though.
Yes, but this is the code inside of insert at front.
Oh,
So we are actually writing the code for insert at front.
okay. You just need to allocate new memory for a new node.
So tell me that, dude. Tell me exactly how I do that.
Okay, right now, because I don't think I quite remember this.
Okay, so that means he's gonna look at the answer. No, I don't want you to do that. I don't want to hear the actual answer. I want that sounds wrong. I want to hear the answer, but I want you to come up with it yourself. Do not look at the solution.
Okay.
All right. So first,
Pointer equal new.
Say that again. Say that again.
The pointer equal new and the object.
Okay. Let me just tell you guys how to do this. I want to build a list node. Correct? So I put the name of my class. Correct? Good. But remember, since I'm building nodes in real time, that means these guys are being built where? On a heap. And for you to build anything on a heap, that means you need to use what?
The new operator.
New. So let me just put a equal here. Don't worry about this part. Let's deal with the right hand side. So new, and new says, what do you want to build, buddy? And I say new, this node of type what?
Int.
Make the fuck that time to tell you that earlier, sir.
Oh, you did, dude? So now list node of type int, right? And we're going to pass in a. Okay? Let me try to write this again. Hold on, let me quickly erase this. Hold on. Let me write this a little bit cleaner so you can see what the heck's going on. Remember, I'm inside of insert at front. Look at what's going to happen inside of that. The first thing is I'm going to say new what? List node of type int. And I need to pass in my value. I'm going to pass in a. All right? New is going to do what? Number one, new is going to go to the heap. New checks how big is a list node. Let's say a list node is 50 bytes. He looks for 53 bytes. He finds it. He builds. He goes to the constructor for the list node. He goes to the constructor. So this means he comes here. And what does the constructor for the list node want? The constructor wants an int. I just give him an int. What does he do with the int? He assigns data to that int, and he sets next to null. That's what the constructor does. So behind the scenes, this is what happens. He builds a list node with the data same as 9. Sorry, in this case. Hold on, where's my pen not working? All right. So in this case, okay. So now what does this do? This builds a list node, right? But then he's going to return a pointer to it. So I need somebody on this side to receive it. So I'm going to say list node, all right, of type int. I'm going to call it new PTR. So this builds the list node, puts in 9 for the data, sets it as null, and let's just pretend the address was 500. Who now points to it? New PTR.
Yeah.
So that's the first line that happens inside of insert at front. Now this built a list node. You with me so far? This built a list node. What's the next step that has to happen inside of this function? You just built a list node. What's the next step?
You have to assign the ending value of it. Now, the next pointer, like the link.
Okay. Remember, this function says insert the front, so that means I need to make this guy the first guy in my list. But I need to ask this guy, are you empty, right? I need to ask my list, are you empty? How would I know if the list is empty right now? What's the simplest question or way of determining if my list is empty?
If pointing to null, I just if
Which one? If what? If what is null?
if first
First
PTR
PTR is null. That means there's nothing in there. So I'm gonna write. I'm gonna check here. I'm gonna write.
if first PTR equals
I'm gonna write if first is equal to null. That means what? My list is empty, right?
empty.
So that means it's empty. Then I'm
Some-
gonna say what? I'm gonna say first is assigned to
the new pointer.
new PTR. So then it looks like this. It looks like this. First will point to this guy. And also, at the same time, I'm going to say last is assigned to new PTR. Because if you're an empty list, when you add a node for the first time,
The
that
last,
node will be the first guy and he will also be the
last guy.
last guy. And I'm done. This is done. You with me so far?
Yeah.
So now if I were to draw what I have so far, this is what I have so far. I have this. So my list object, first, 500, last, 500. And it looks like this. That's what it looks like so far. So what if I come back here and I call this function insert to front again? So I do li and I do insert at front.
So you have less than a minute, I think. Time out.
Okay, when time's up, I don't know if you want me to continue and just give you another extra 5 minutes explaining this, or you want to just wait till
Okay.
then.
You could give an extra 5 minutes.
Okay, so what I can do is when this ends, I'll relaunch the same session and I'll just give you an extra 5 minutes just to show you how we add 3 nodes total. Then you can look at the code later on, make sense, okay? You don't have to show up, but it's up to you if you want to.
I guess everybody get it from the first logic. The circuit, the logic just repeat it.
So, I mean, it's up to you. I'll give you another 10 minutes, but I'll relaunch it and then do another 10 minutes. So in this case, if I do insert at front B, remember the B had the value of 15, right? 15. So what's gonna happen? Same thing. He has to build a list node, right? He has to build a list node. And how does he build a list node? We know the process. So then it's gonna be list node int PTR is assigned to new whatever, right? This will build one of these. He's going to call the constructor for list node and he's going to put in B, which was 15. This will be null. Let's pretend this guy's address was 9,000. And who's pointing to this guy? Who knows where this guy is? New PTR. This guy just built this. Is he part of my linked list right now? And right now. Is this guy part of my linked list right now? No. Launch a thing like that. Okay, so I think that's everybody who's going to come. Let me share my screen. Sucks.
All right, sir.
Okay, so so many people. Okay. Ooh. All right. So back to okay. In the meantime, let me just draw what I had before. So we had first, last. This is called li. Contain 500, 500, and they both point to this guy. Contains 9. And then I did another insert, and the insert built this node, getting 15, null, who knows where this guy is, new PTR, and let's pretend this guy's address was 9,000. All right? Now, what's going to happen? Remember, we just called insert at front a second time. Insert at front. When I'm finished, I want you to imagine, when I'm finished, where should this node be placed in this diagram?
In front of the nine block.
In front of this, right? This guy should be here. So that means his next should point to who? This guy, correct? And then this guy would be the first. This would be the new first. And then this guy will keep on being who? The last. Does that make sense?
Yeah.
So how do I do that? I just built the node. I just built it. But he's currently not the first guy. I just built it. He's not the first. So how do I make him the first? Give me the logic. The order in which you do this is very important. You built the node. Who knows where the node is? New PTR. How do I somehow make this guy the first guy and this guy the second guy? Remember, first and last are pointing to this guy. How do I attach him to this list now? How do I do that?
Okay, you just say first you assign first PTR to the new node you just create.
Okay, so now I'm going to listen to what Gilbert said. He said, just write this code. He said, say first is assigned to new PTR, correct? If I do that, immediately what happens? This is broken, and he immediately comes and he points where? Here. Is that correct?
Hold on, make it think about it. Okay.
Is that correct? Carne asada way. Is that the first step you should take?
No.
No, let me tell you why. What if you had this? What if you had this, right? First and last, and this is what it looked like. What if this was your situation, right? Okay, if this was your situation, and I did what you said, right? I built this new node with 15, and I wanted him to be the front. You said, break this and point here. Break this. What? Move and break this and point there. What's gonna happen now?
Yeah, the
You
list
lose
get,
connection, man.
Huh?
the list get broken up.
The list is broken. Your list is permanently gone. This is called a memory leak. You know why? You can't get back these anymore. They're gone. They're gone.
Yep.
They're in the heap, and the heap thinks that they're being used, and nobody knows where they are anymore. So you can't just attach first to the new guy. What do you have to do? What do you have to do so that you don't lose this guy? No. How do I not lose this? I don't want first to point him immediately. What's the first step I should take instead? Come on, guys, it's just logic. I need this guy, huh?
You could just point last PTR to new PTR.
No. No. You don't want to touch last PTR. How do I do it? I can't do it like this. How do I do it? Okay, I want you to understand what's going on. I have a new node. I need this guy to be at the front. If I just say first point to this, then first stops pointing to this one, and nobody knows where this guy is. So I can't have him point to him. So the simplest thing is what? Who knows where this node is? New PTR. All I need to do is what? All I need to do is what? All I need to do is tell new PTR, yo, new PTR, your next should point to whatever first is pointing to. So instead of writing this line, I would write what? new PTR, next PTR
Can I choose a save on the tag
is
there?
assigned.
Oh.
If you're wondering what the hell is this arrow, right? This arrow is the equivalent of doing two things. If I want to have access to this part, how do I get access to this part? Well, this is a pointer. New PTR is a pointer. How do I get access to this part? Now remember, a pointer that points to an object, you have different parts within that object. How do I get to this part of the object? So normally I would dereference the object at the pointer. It's a new PTR, dereferenced. What does that do? That takes you here. You understand? When you dereference this pointer, it takes you here. You got 9,000. But 9,000 is the beginning of the node. I need to get just this part. I need to access to just this part. How do I do that? Then I'll do dot next PTR. Understand? This gives me access to the node. Dot next PTR gives me access to this part. Does that make sense? But instead of writing it like this, which is much longer, C++ says you can just write new PTR arrow
Or
next
even
PTR.
if you write the period next PTR, it changes into the arrow still.
Okay, all right. So that's a feature, I guess, with the new version of Qt. But the point is, this is what you would have to do. All right? Either do it this long way or just do it this way. So the arrow is a dot and dereference and a dot. So now what is this thing? This says new PTR, arrow next PTR. This says new PTR, dereference it, you're here. Then give me the next part, which is currently null. He says, in this part, I want you to store whatever is inside of first. What's inside of first? What's inside of this?
Nine.
Remember address of the first one.
500, right? So he says, put 500 in there. So that causes this, right, to point to the first guy. But first is still pointing to this guy, right? First is still pointing here. He doesn't know that this thing has changed. Right now we have right now we have new PTR pointing to this guy. I need now to tell first PTR, this is no longer the first guy. This is the first guy. So after I do this line, then I'm going to say first is assigned to whatever new PTR is pointing to.
Yeah, so I'm meant
It's going to get updated to 9,000. So now first stops pointing here, and now first is going to point here. So visually, what you end up with is this. This is your list object. This is first. This is last. 9,500. This points to this guy, which was 9. Right? And then we built this new guy, which has 15.
Then
Points to this. That's what it looks like. Does that make sense? And if you do one more insert, let me just do one more insert. If I do one more insert, the same code is going to appear, right? Build a list node. Let's say that the value is 21. New PTR knows where he is. And let's say his address is 600, right? I want this guy to be the new first guy. So what do I do? Same thing. I say, what? This guy's next. This guy's next is assigned to whatever first is. So that's going to say, make it into 9,000. So now that's going to look like this. And then I need first to stop pointing here, right? I need first to stop pointing there. And I need first to point to the new guy, which is 600. And that's going to look like this. So this is the first guy. This guy points to this guy, and then this guy points to this guy. Does that make sense how we insert at front?
I see, said the blind man.
And this is the code for insert at front. This is it. Let me just show you the code so you can see. We call get new node. That's a function. This is the function, right? Get new node. And then what's going to happen? We check to see if it's empty. We always have to check to see if it's empty. Why? If it's empty, what's going to happen?
Then start in a.
Then you are the first and you are the last. If it's empty, you are the first and you are the last. But if you're not empty, then I'm going to take your next and I'm going to assign it to first, and then first will assign to new PTR. Does that make sense?
Yes, sir.
Okay, I'm going to have you do something for me. You can do it in pairs. I'll come up with it, but you're going to have to write the function for me. You can do it in pairs. I'll let you know what that function is. But I need for you to tell me if you understand this code before I continue. Before I'm going to end. I'm going to end. We've gone over time. I just wanted to finish this one function. Do you have any questions about this?
Nah.
Okay. So please review this code. Review this code because I'm going to ask you to write a function for me that does something very specific. If you understand how this works, then you can do that function for me. Does that make sense?
Yeah.
Okay. All right, guys. That's it.
Well, yeah. When you give the word next class.
No, I'll probably send it out today. It's going to be due. I'm going to tell you when it's going to be due.
All right.
Sir, so no
I
quiz,
read
right?
it, sir.
Or yes, quiz.
When? For what? Thursday?
I don't, yeah.
This thing that I give you might be your quiz for Thursday. So,
Oh, okay.
so I need
Will
to,
you still be recording
because that's
video?
the only way I can force you guys to practice the code. And as you see notice now, right? The code is getting more complicated. So I can't afford to have you guys take it easy. Now it's going to start to build. It's going to get more complex. So I have to make sure that you are actually practicing. All right? And that's the
Will
only
you
way.
be doing more videos, sir? Or no?
I'll try, but like I told you, that stupid, ridiculous class is just eating up my time. So
Drop the class, sir.
I can't.
They're just still there.
I can't. I wish I could drop it. I told them I don't want to teach that stupid class, but I have 70 students in that one class. 70.
Like the
So
Sir, look, everybody on the ass, I really don't want to teach you. Know. They just feel this.
Give them all an A.
so that's just one class, 70 students, and then I have all my other classes which are jam packed, right? So it's a lot of work for me. I barely have time. Like I'm always up until like grading until or preparing stuff until like 1, 2 a.m. I'm tired. Like, train. If I have time to make videos, I'll make videos. But I can't promise you guys at this point that I can produce them really quickly. It's just too much. All right. So in the meantime, just review the code, and I'm going to send you what what your quiz is going to be. It can be done in pairs, and then hopefully you can have that done. And by doing it, trust me, you're going to learn how this works. The first thing, if you really want to test out if your code works, let me just say this before we go, right? At the minimum, what I want you guys to do is I want to see if you can take this code, all right, and make it compile and run. And the only thing is, I want you to understand, template classes can only appear in an H file, in a header file. You cannot separate. You see this part? You see this code right here? Normally, we would put this implementation in a list.cpp file. All your code, list node, will go in a file called listnode.h, and list, all the code for list, the declaration and the implementation will go in a file called list.h. You do not split template classes into a .h and .cpp. So that's what I want you to do for now. Before I give you that little quiz, please work on that because that's the first step. Once you get this code to work, all right, you can just copy and paste this code. If you get that to work, then when I give you something to practice, you can see if your code works because you just have to plug it into this class and then it should work, all right? So that's how you do it. Just copy and paste this code, put all the code for the list, right? List node, let me just show you. All the code for the list. Take all of this code, you see this? The declaration and the implementation, put it in a file called listnode.h, put it inside of this file, all right? And then take all of this code, the declaration, implementation, everything, and put it inside of a file called list.h. And then with that, you can just create a driver program and you can test it. Okay, guys? Do that. That's the first thing to see, at least that you have a working program. And then I can give you exercises and you can plug it in and immediately you can see if your code works. All right, guys. So I'm gonna end off here because I'm well over time, and I apologize about that. I don't like going over time, but I had to finish this so you understand it. So just look out for that, and hopefully it'll make sense to you. All right. Take care. We're just
Yeah, sir.
about to close the program.
Take care, sir.
All right, no problem, guys. Take care.